Hello everyone, and welcome to this example recording on source transformation. So this question reads, determine Ix using source transformation. So if we quickly analyze this circuit before starting, we'll notice that it has a combination of dependent as well as independent sources. And we will remember that source transformation is not only applicable to independent sources, it's also applicable to dependent sources. So we are then going to simplify this circuit to a point where we can calculate the value of Ix. Right, so my simplification, I'm going to start on the left hand side by converting this voltage source in series with a resistor to a current source that's in parallel with the resistor. The value of the current source will be 20 divided by 5, which is 4 amps, in parallel with the 5 ohms and the 5 ohms, and that's Ix. So I won't interfere with this resistor because I am trying to determine the current flowing through that resistor. Now what can I do here? First, I can get the parallel combination of these two resistors. So we should know that 10 ohms in parallel with 10 ohms will give you 5 ohms. Then I know that I've got a 5 ohm that is sitting in parallel with a 6 amp current source, which I can convert to a resistor sitting in series with a voltage source. And the value of the voltage source will then be the resistance, which is 5, times the current, which is 6, which will give you 30 volts. Also important to note the polarity of my voltage source, right? In terms of polarity, that would be negative to positive from a source side, so that would be minus plus in that direction. Alright, then what I can do on my right hand side, we'll notice that I've got 3 current sources, 1 dependent, 2 independent, and a resistor in parallel. I can add all of these current sources together to then result in one current source, and the value of this current source will be 3Ix plus 2 plus 0.5. So it will give me a final value of 3Ix plus 2.5, 2 and 0.5. Rather, it should give you a value of 3Ix. 3Ix is going in, 2 is going in, and 0.5 is going down. So 2 amps going up and 1 amp going down will give you a resultant of 1.5 amps. So this should actually be 3Ix plus 1.5. And that will be in parallel with the 10 ohm resistor. Okay, next step would be for us to convert this to a voltage source so that we can add it in that branch. So we'll still leave this part of the circuit as is, as well as this part of the circuit. And what we're going to do here is we're going to convert this to a resistor in series with a dependent voltage source, and the value of the dependent voltage source will be 10 times 3Ix plus 1.5. So that will give me a value of this voltage, which will be 30Ix plus 15, and it will still be 10 ohms, 30 volts, 5 ohms, 5 ohms, 5 ohms, and 4 amps. The next step would be for me to add the resistances together to give me one series resistor. So that series resistor will be a 10 plus 5, which gives me 15 ohms, and then also put the sources together, right? So if I notice here, I first increase by 30ix plus 15, and then I decrease by 30. So the final value of the source should be 30ix plus 15 minus 30 volts, which should give me 30ix minus 15. Right, next thing I'm going to do is convert this to a current source in parallel with the resistor. So I'm going to have my resistor and I'm going to have my current source, which then connects to the remaining circuit. Right, and that is the 5, that's the 5, this is Ix, this resistance value here will be 15, and this will be, this current should give me a value that's going to be 30Ix minus 15 all divided by 15, which then should give me 2Ix. 30 divided by 15 will be 2, and then 15 divided by 15 will be 1. So I've got a value here of 2Ix minus 1 in parallel with the 15 ohm resistor. Okay. Next, we will further simplify the circuit. We're looking for Ix, so we should be able to add these two currents together. They are in parallel. We should also be able to put these two resistors together since they are also in parallel. So if I then calculate my resistance, it will be 5 in parallel with 15. And it gives me a value of 3,75 ohms. So I'm going to have a current source, a resistance of 3,75 ohms, and a resistance of 5 ohms with the current Ix. What will the value of this current be? It should be the addition of 4 and the 2Ix minus 1. So it will be 2Ix plus 4 minus 1, which will be plus 3. Right, now I need to determine the value of Ix. I should be able to use current division for that. So I can say Ix is going to give me 3,75 over 3,75 plus 5, all multiplied by the source, which is going to be 2Ix plus 3. Alright, so Ix is going to give me, and if we just get that ratio, 3,75 divided by 3,75 plus 5, what does this give us? It gives us a value of 0,428. So this is going to be 0,428 multiplied by 2Ix plus 3. So Ix is going to give me, I'll quickly multiply that out. So if I multiply that by 2, it's going to give me 0,857 plus 3 times 0,428, which gives me 1,284. Right, now I can make Ix the subject of the formula. So I can say Ix 1 minus 0,857 is equals to 1,284. Ix is going to give me 1,284 divided by 1 minus 0,857. And that gives me a value of 8. Gives me a value of 8,97. Right, so we've taken the circuit at the very beginning and we've simplified it using source transformation all the way to getting a current division circuit, which we then used to determine the value of Ix. Thank you for watching this video and enjoy the course.